In this video, we're going to talk about tests for equality of variances, and we're going to conduct this test on the data file student grades. So whenever we want to check the equality of variances, the process is exactly the same. We need to take two samples, one from each populations, and then take the sample standard deviation or sample variance as our sample statistic. And then given the sample statistics here, sample standard deviation, we can go ahead and find the test statistic F, capital F, which is simply the variance of sample 1 divided by variance of sample 2. And this test statistic follows the F distribution, So the F distribution, unlike the other type of test that we've been talking about so far, like T distribution, like standard normal distribution, F distribution is not symmetrical around 0. An F distribution actually takes two parameters, N1 minus 1, N2 minus 1, sample size 2 minus 1. So it has 2 degrees of freedom. It's a much more complicated distribution than the T distribution and standard normal distribution that we're not going to go into the details of this distribution. But just one thing that might be important when we're conducting this type of tests is that since this is not a symmetric distribution, Excel will not provide us with p-value two-tailed. As you can see here, the type of test that we are conducting here, this is a two-tailed type of test. If you just look at the signs here, it's a two-tailed type of test, but the distribution is not symmetrical. Excel is not going to provide us with the p-value two-tailed. So it's up to us to make the adjustment so that we can use the p-value that the Excel test is going to give us in order to be able to perform a two-tailed type of test. So I'm going to go to the Excel file, and I'm going to show you how to do that. So if you go to the Excel file, student grades. So in this data file, we have for 56 students, we have their midterm score and we have their score at the final exam. So we want to test and see if the variance of midterm exam is the same as variance for the final exam. And then the alternative would be if they're not equal, right? So this is the null and alternative. And I'm going to fix the level of significance to 5%. Again, so that's the level of significance. And now let's go ahead and use the F-test for comparing the variance, for testing to see if their variance is equal or not. So if we go to Data tab, Data Analysis, F-test, two sample for variances. Okay, so variable 1 range. So I just put midterm first here, so I'm going to use midterm. Again, this is a two-tailed type of test. Excel is going to provide us with just one p-value, one tail. So it really doesn't matter which one you put first. It's going to affect the test statistic, all right? But it's not gonna affect the p-value. So it doesn't really matter which one you put first. So I'm gonna go with the midterm first and then final next. So midterm, final, and then I have the labels. So I check labels, alpha 5%, that's perfect. And then I put it in somewhere on the same sheet, okay. All right, so I have a bunch of numbers, but at the end of the day, what matters to me is going to be the p-value. In order to conduct this hypothesis testing, I just need a p-value two-tailed. This is a two-tailed type of test. And I need p-value two-tailed, but Excel only gave me a p-value one-tail, all right? So it's very simple. P-value two-tailed then would be p-value one-tail. Before we had 2 times for p-value two-tail, 2 times minimum of upper and lower tail. So this is actually the minimum of lower tail and upper tail. So this is the minimum. So you just, if you just multiply this by 2, it will give you the p-value two-tail. All right, so now we have the p-value two-tail. This is what we were looking for. So we just need to compare this p-value two-tail with alpha, and then since p-value two-tail is greater than alpha, we fail to reject the null hypothesis. And so the conclusion is that we do not have enough evidence to say that their variance and their variances are different. So basically, this test confirmed the equality of variance. So that's basically our conclusion. So p-value two-tailed is greater than alpha. We fail to reject the null hypothesis and conclude there is no meaningful difference between variances.